Okay, study guide test 2, rational functions. All right, asking us to add or subtract and state excluded values. So we have a subtraction problem. What I always like to do is like to take that minus sign, turn it into a plus, and then distribute the negative sign into the numerator of the fraction behind it. So now it's a negative 4x and a plus 1x. From there, we're doing any addition or subtraction. So we care about like denominators when we are doing this type of problem, and you'll notice that we have an x plus 2 as denominators for both fractions, which means we can add our two fractions together. And when we do that, we keep the denominator the same. So in the numerator, we'll have a 5, a minus 4x plus 1. And then we just simply combine like terms. So we'll have negative 4x plus 6 over x plus 2. All right, from there, it asks us to state excluded values. So those are the x values in the denominator. So here we have an x plus 2. So the number that x cannot be would be negative 2. And we get that by asking the question, what number plus 2 is equal to 0? Our second problem, doing the same thing. This time it's a plus, so we don't have to do any extra work with the signs. Now, you can look at the denominators and you can see they are different. We do need to factor them to see if they have anything that is the same. So use the box method of factoring to help us figure those out. So I'm going to make my box. I'm going to put the x squared here, the 6 here, and the 5x over here. I'm going to go x squared times 6, which is 6x squared. Now I need to figure out two numbers that multiply to be 6, but would add to be 5. That's going to be 2x times 3x makes 6x squared, and then 2x plus 3x is 5x. So x times x gives us x squared, x times 3 is 3x, and x times 2 is 2x. So down here I have x plus 2, x plus 3. And so we're going to do the same thing for the other trinomial in the denominator, x squared negative 6, 1x. We multiply x squared and negative 6 to make negative 6x squared. So here we need two numbers that multiply to be negative 6, but adds to be 1. 3x minus 2x. So 3x take away 2x would give us the 1x, and 3x times negative 2x is negative 6x. So x, we'll get a negative 2 here and a 3 here. So x plus 3, x minus 2. So now looking at our denominators, now that they're factored, we can see that they share an x plus 3, but the fraction on the left is missing the x minus 2. So I'm going to bring in an x minus 2 to top and bottom. And on the fraction on the right, in the denominator, it's missing an x plus 2. So I'm going to bring in an x plus 2 to the left. So now that I have that, I have my left fraction with a denominator of x minus 2, x plus 2, x plus 3. And on the right, same thing. All right. Now in the numerators, we have ourselves two binomials on the left, the x minus 2 and the x plus 4. We need to multiply those out. You can use your distributive property arrows to do it. I'm going to use the box just so I don't miss anything in my multiplication. So I have an x minus 2 and x plus 4. And I'm going to times them together. So I get x squared, 4x when I multiply the x and the 4, and then x times negative 2 is negative 2x, and negative 2 times 4 is negative 8. That's going to give me x squared. Now 4x, take away 2x is 2x, and then I have my minus 8. I'm going to do the same thing with the two binomials on the right here. I have an x minus 3 and an x plus 2. Going to multiply them together. X times x, x squared. X times 2x is 2x. X times -3 is -3x. And -3 times 2 is -6. So we'll have x squared -3x plus 2x is -1x minus 6. Now I can go ahead and add my two fractions together. And in the numerators, I'm going to combine like terms. So x squared plus x squared is 2x squared. 2x, take away 1x is 1x. -8 minus 6 more is -14. It does ask to state excluded values. So in the denominators, I would get +2, -2, and -3. Just remember, it's always like a sign switch of these is your excluded values. And we've got our answer. Okay, another problem on addition and subtraction. So when I'm looking at the denominators to see if they're the same, I can tell they're a little different. One is x minus 6 and one is 6 minus x. Now in class, remember I told you if you ever see 6 minus x or a number minus x, it really means -1x minus 6. Don't forget your -1. So now when I look at my denominators, they look almost the same, but the one on the left is missing the -1. So I just need to multiply that in. So -1 times -1. All right, in the denominators, we now have a -1 x minus 6 in both fractions. On the left, I'm going to distribute the -1 to the x and 5. So I have -1x, -5. Nothing's happening to the one on the right. It's just going to stay x minus 2. Now we can combine the two fractions with addition. Combine our like terms on top. -x plus x would be 0. -5 minus 2 is -7. State the excluded value. So what number minus 6 would equal 0? +6. And we've got it. All right. Moving on to multiplication/division problems. State the excluded values. So for multiplication, I always like to start off the problem by factoring. So in the first fraction, there's nothing to factor, but in the second fraction, there's that trinomial on top, x squared plus 4x minus 60. I am going to factor that. All right, so I need to figure out two numbers that multiply to be a -60, but would add/subtract to be a 4. So I'm going to go with a 10x and a 6x where the 6 is negative. All right, so now we'll have x times x makes x squared, x times -6 would give us the -6x, and x times 10 would make the 10x. All right, so here I now have x plus 10, x minus 6. Now that I've factored everything, I want to go ahead and start off by stating any excluded values that I have. Remember, those come from the denominator. So what number plus 10 would equal 0? -10. What number minus 9 would equal 0? +9. Once I've stated the excluded values, I can go ahead and start simplifying. I have an x plus 10 in the numerator and an x plus 10 in the denominator, so they're going to cancel. Nothing else cancels out. 1 times x minus 6 just gives us x minus 6 in the numerator, and then we have x minus 9 in the denominator. And you're done. Okay, our next problem. So once again, we want to start off with any factoring first, and I notice in the first fraction on the bottom, I have an 8 minus x. Once again, that really means -1x minus 8, and we should write it in like that. In the second fraction in the numerator, there's two terms with a bunch of numbers and variables, which tells me it's probably a greatest common factor. So looking at 7 and 56, 7 is the greatest common factor for the numbers. For the variables, we have x to the third, x squared, so they share at least two x's. And so now to finish off the factoring, now that we have the greatest common factor, 7x squared times x would make the 7x cubed. 7x squared times 8 would make the -56x squared. So now that I've done all my factoring, we can start stating our excluded values. So once again, they come from the denominator. We look to the x's. We have x minus 8, which means the excluded value would be positive 8. And that's it. Those are all the excluded values. So now we can start simplifying. We have an x minus 8 cancels out the x minus 8. And that's it. So in the numerator, we are left with a 7x squared and a x plus 5. In the denominator, we have a negative 1 and a 9. So negative 1 times 9 is negative 9. And we've got our answer. Division. So with division, we have to state excluded values. We have to check for them multiple times. But we're going to start off by factoring. So to factor, we're going to have to make some boxes. For the numerator on the first fraction, we're going to need a box to factor that. So I need two numbers that multiplied to be 56, but it's going to combine to give me 15 or negative 15. So I'm going to go with negative 7x, negative 8x would make that work. So my factors are going to be x minus 7, x minus 8. I'm going to do the same thing with the other trinomial on the right. All right. So two numbers that multiply to be 40, but adds to be 13. I think that is 8 and 5. Yes. So negative 8x, negative 5x. So we're at negative 8x, negative 5x. In the denominator, I notice I have a 3x minus 12. They have a greatest common factor of 3. So it would be this. And those are all the things I can factor. Now, before I do anything else, now that I factored, I am going to state excluded values in the denominator. So I go to x minus 4, the excluded value would be positive 4. I go to the x minus 5, excluded value would be positive 5. Now, since we're doing the division here, okay, we're going back to middle school. Keep, change, flip. So I'm going to keep the first fraction the way it is, x minus 7, x minus 8 over 3x minus 4. I'm now going to change the divide to a time sign. Then I'm going to flip the second fraction. And now when I've done that flip, new x's show up in the denominator. So I have to state those excluded values. So I go to x minus 8, which means the excluded value would be positive 8. X minus 5 is 5. Before I got that one, we don't have to write it again. So now we can go ahead and start canceling things out. So I have a x minus 8 cancels out an x minus 8, and x minus 5 cancels the x minus 5. So I am simply left with x minus 7 over 3x minus 4. Our next division problem, our first one in the numerator, we have 16x squared minus 9. Looking at that, there's two terms. 16 and 9 don't have anything in common, but 16x squared is a perfect square, 9 is a perfect square, and we have a minus sign. So that tells me that's a difference of squares. So to review how to factor a difference of squares, we'll have a plus and a minus. I square root the 16x squared, which would give me 4x, and I put that in both positions here and here. And then I also square root the 9, which gives me 3. And I have factored a difference of squares. In the other fraction, I see a 20x minus 15. They have a greatest common factor of 5. So I would have 4x minus 3 here. Now this is division, so I do want to state my excluded values after I do my factoring. So I look to the 6x and I ask the question, what number times 6 would equal 0? 0. Then what number plus 1 would equal 0? -1. Now I'm going to go ahead and do keep, change, flip. So first fraction will stay as 4x plus 3, 4x minus 3, then 6x, change to a times, and then flip, x plus 1's on top, and the 5 times 4x plus 3, minus 3 is on the bottom. Now that there's new x's on the bottom, I need to go ahead and state the excluded value for that. So technically you're asking what number times 4 minus 3 would equal 0. You can do this algebraically by doing 4x minus 3 equals 0 and solving the equation by adding the 3 over, then dividing by 4, and you'd get 3 over 4 as your other excluded value. Once again, you can do that mentally in your head. You can see you have the minus 3. Notice how the sign switches and it's positive 3 for the answer. And then the number in front of x ends up in the denominator. That always happens, so you can always do that mental shortcut we've done in class. Now I can go ahead and start canceling. The 4x minus 3 cancels out the 4x minus 3. And that's all that cancels. So we're left with 4x plus 3 and x plus 1 over a 5 times 6x, which is 30x. All right, let's look at some graphing problems. All right, so first thing we want to do when we see that they are unfactored, our equation up here is tackle the horizontal asymptote. So as you remember that if the two highest degrees are the same, which we have here as x squared, those are the highest degrees, the leading coefficients should be divided because they're the same degree. So in the leading coefficient I have is a 2, underneath is an invisible 1, so 2 divided by 1 is 2. And the horizontal asymptote should be written as y equals 2. All right, once we have that one, the next thing we want to do is start factoring. So in the numerator, I notice a 2, 4, and 30. Those are all even numbers, so they are a factor of 2. So I can do a GCF to try to make my numbers a little easier and more manageable. So taking out a 2, I'll have x squared. 2 times negative 2x would make that negative 4x, and then 2 times negative 15 would give me that negative 30. In the denominator, I'm just going to leave that the way it is. Actually, I'll just do it now. We have x squared minus 4. This is a difference of squares, and that's because you can square root the x squared. You can square root the 4 and get a nice whole number, and there's a minus sign. So I have two parentheses, one with a plus, one with a minus. The square root of x squared is x. The square root of 4 is 2. Now we do have this x squared minus 2x minus 15 in the numerator, which I need to factor. So I'm going to go ahead and use the box method to do this. You may have noticed by now that there's a lot of factoring. If you have trouble factoring, you need to talk to your teacher and help you get better. Without it, you're going to really struggle on this test. So two numbers that multiply to be negative 15, but combines to be negative 2 would be a negative 5x and a 3x. So x, 3, and negative 5. So our equation will look like this. All right, so now it's all been factored. We can go ahead and start pulling information. Vertical asymptotes. Well, first thing, let's look at it. Is there a hole? Looking at the numerator and denominator, there are no factors that cancel out. So therefore, there is no hole in this problem. Next thing would be vertical asymptotes. Now remember, those come from the denominator. So we get those by asking what number minus 2 would equal 0? Positive 2. So one vertical asymptote is x equals 2. I go to the next one, what number plus 2 would equal 0? Negative 2. So the other vertical asymptote is at negative 2. X-intercepts, those come from the numerator. So we look at the x's in the numerator, and we ask the same question, what number minus 5 would equal 0? That's going to be positive 5. So 5 comma 0. We go to the next one. What number plus 3 would equal 0? Negative 3. So here is my other x-intercept. This one does ask for the y-intercept, which simply means that if you make the x 0, you would find the y-intercept. So I'm going to replace all the x's with zeros in my problem. And then I'm just going to do some basic math. All right, so I'm going to have 2, negative 5, 3, negative 2, and 2. So negative 10, that's 30. And that's negative 4, so that's going to give me a decimal of about 7.5. So my y-intercept is 0, 7.5. All right, so now that I have kind of a lot of the key information, except for domain and range, I want to see my graph before I try to answer that question. I'm going to go ahead and plot the information. So I'm going to do the vertical asymptotes first. I have one at positive 2. So I have a dashed line going up and down here. I also have one at negative 2. Horizontal asymptote is y equals 2, so that's going to go here. And then our x-intercepts are at 5 and negative 3. Our y-intercept is at 0, 7.5, so that's right up here. So now we can kind of start graphing. Remember, we're going to do the left and right sections first. So these are going to follow the asymptotes. Follow the asymptotes. Now, remember, on the inside, they have to go in opposite directions with the asymptotes, with the lines on the other side of the asymptotes. So what I mean is this. So if I have a vertical asymptote, okay, and on the left side of it, the line is going up, then on the other side of that asymptote, the line has to go down. Just like if I have here the line going down on the left side, then on the right side of that asymptote, the line would have to go up. So they have to go in opposite directions. So over here where I have my arrow pointing down, on the other side of that asymptote, the graph must be going up. And since I have a point, it's probably doing something like this. Now, you can see that on this side, the graph is heading down, so on the other side, it has to go up. That's why it's kind of making some kind of U shape. Not exactly sure if it looks like that, if it goes down a little bit more. I just know that it's going up in both directions inside that little circly part. So from here, I'm going to go ahead and state my domain. Once again, the way I do it in my class is x is an element of all real numbers, but it cannot equal the vertical asymptotes or holes. We don't have any holes, so it's just going to be 2 and negative 2. The range for this problem, given what our picture looks like, this once again may not be a perfectly representative of the graph, but given what we have, y is an element of all real numbers, and it won't be the horizontal asymptote, so y cannot be 2. Okay, our next problem. This one's pretty nice. It's been pre-factored for us, but since it's been factored, we have to do a little work to find our horizontal asymptote. So to find our horizontal asymptote, we need to know what the highest degrees are. So here in the numerator, I have an x times an x. So x times x makes x squared. Once again, I get that by multiplying, right? That means I don't have a number in front of the parentheses, so my leading coefficient is 1. In the bottom, I have an x times an x, so I'm going to get x squared again. But there's not a number in front, so the leading coefficient is 1. Since the degrees are the same, the leading coefficients divide. So 1 divided by 1 is 1. All right, so now that I have the horizontal asymptote, I want to go ahead and start looking to see does anything cancel to make a whole. And I notice an x minus 1 and an x minus 1 in the numerator and denominator, so they do cancel, making a whole. And to figure out its location, you ask the question, what number minus 1 would equal 0? It would be at 1. So now my new equation is x plus 3 over x plus 2. Vertical asymptotes come from the bottom. And so what number plus 2 would equal 0? Negative 2. x-intercepts come from the top. What number plus 3 equals 0? -3. From there, the y-intercept, once again, the x is 0 for your y-intercept, so I'm going to go ahead and plug a 0 into the equation. So I'll have 3 over 2, which is really 1.5. So I have a y-intercept of 0, 1.5. I'm going to leave the other 3 for once I have the picture to kind of have a better understanding of what those answers would be. All right, so vertical asymptote is at -2. Horizontal is at 1. We have an x-intercept at -3 and a y-intercept at 1.5. Now, in this problem, we actually have a point in each section, so we don't have to find an extra one or anything. And we follow our asymptotes. So following the asymptote. Now, we gotta be careful. We do have a hole at x equals 1. So when I'm drawing my picture and I curve, and when I get to where x is 1, I'm going to make an open circle, and I'm going to keep on going to represent my hole. All right, so now it asks for domain. So domain is going to be x. X is an element of all real numbers, but it can't be any vertical asymptotes or holes. So it can't be -2, as also cannot be +1. Our range, y is an element of all real numbers, but it cannot be where y is 1, and that's because that's where the horizontal asymptote is. Increasing interval, looking at this problem, remember increasing interval is when as you increase x's, the y values increase, making like a graph that curves up. We don't have a section of the graph that's doing that, so there is none. There's no increasing interval in this problem. All right, our next graph. So this one is in graphing form, as we've talked about. When it's in graphing form, it makes it a lot easier. So we have ourselves 2 over x minus 4 plus 5. So remember, that's going to be a over x minus h plus k. The h is the vertical asymptote, the k is the horizontal asymptote, and a helps us figure out how to count those nice little 4 key points that makes graphing a lot easier. So in this problem, vertical asymptote, what number minus 4 would equal 0? +4. Horizontal asymptote has a 5, so therefore y equals 5. In this does not represent any holes because there's no x's in the numerator to cancel out with the x's in the denominator, so there's none. To find an x-intercept, we are going to plug in a 0 in for y and solve. Okay, so we have to plug a 0 in for the y. So we have 2 over x minus 4 plus 5. I would minus the 5 over. And now we'd want to solve this. So I would multiply both sides by the denominator. So I'd have 2 equals -5 times x minus 4. Distribute the 5, so I've made a 5x plus 20 equals 2, minus the 20 over, that's -18. Divide by -5, x is going to be 3.6. The y-intercept is when we take a 0 and plug it into x. So we'll have 0 minus 4 plus 5. We're going to have 2 over -4 plus 5, so that is going to give us a -1/2 plus 5, so that is 4.5. All right, so let's go ahead and do some graphing. So asymptote is at x equals 4. Y equals 5. Okay, we have a x-intercept at 3.6, a y-intercept at 4.5. All right, so to use our skills to graph using our 4 key points, we have a 2 in the numerator. So if we go where the asymptotes cross, we can go up 1 over 2, over 2, up 1, going the other direction for the asymptotes cross, over 2, down 1, down 2, over 1. And so now we can go ahead and graph our graph. Okay, so domain, x is an element of all real numbers, but it can't be any vertical asymptotes or holes, which means it can't be the number 4. Range, y is an element of all real numbers, but it cannot be the horizontal asymptote, which is 5. Increasing interval, once again, an increasing interval is when you're increasing the x's and the y's get bigger, which means you should see something that's going like upwards or curving upwards. We don't have that, so there is none. All right, finding an oblique asymptote. This is using your long division skills from second quarter. So we're going to write it as the long division problem, 45x squared plus 58x plus 21 being divided by 9x plus 8. So we have to figure out what number 9x times what would give us 45x squared. That's going to be 5x. So I'm going to line that up with the 58x here. So 5x times 9x is 45x squared. 5x times 8 is 40x. Draw your line, switch your signs. You're going to get 18x, drop down the 21, and we kind of go through the process again. We're asking the question, what times 9x would give us 18x? That would be 2. 2 times 9x is 18x. 2 times 8 is 16. Draw your line, switch your signs. It doesn't really matter what happens after this because the problem has ended, and what's in top, the 5x plus 2, is your oblique asymptote. Okay, another problem doing the same thing. All right, so we're asking the question, 3x times what would give us 24x squared? 8x. So 8x times 3x is 24x squared. 8x times negative 4 is negative 32x. We're going to draw our line, switch the signs. The first are going to cancel out. 32 minus 5 is 27x. Drop down the 42. And then we are asking the question, what times 3x would give us 27x? That would be 9. So we'll get 27x. 9 times 4 is, 9 times negative 4 is negative 36. Draw your line, switch your signs. This doesn't matter anymore because we have nothing else to drop down. So the oblique asymptote is y equals 8x plus 9. Okay, simplifying and stating excluded values. To simplify, you need to factor. So in the numerator, factoring using the box. This time we'll need a negative 10 plus 6 to get the combination right. X, 6, negative 4. So in the numerator, we're going to have this. In the denominator, we have the greatest common factor situation happening. A 3 and an 18 have a 3 in common. x squared and x, they have an x in common. And so 3x times x would make 3x squared. 3x plus 6 would make the 18x. Now we're going to state excluded values because we factored. So we go to what number times 3 would equal 0? 0. What number plus 6 would equal 0? -6. Now the x plus 6's can cancel out, leaving the answer x minus 10 in the numerator and 3x in the denominator. 14, same thing. In the numerator, we're going to factor with our box. Two numbers that multiply to be 63x squared, but adds to be 16 is going to be a 7x and a 9x. So we're going to have, okay, in the denominator, x squared is a perfect square. We have a minus sign, and 81 is a perfect square. So this is a difference of squares. So we're going to have a plus sign and a minus sign. We can square root x squared and get x. We can square root 81 and get 9. I'm going to state excluded values. What number plus 9 would equal 0? -9. What number minus 9 would equal 0? +9. Then we can start canceling out things that are the same, and we're left with x plus 7 over x minus 9. Okay, solving and check for extraneous solutions. Okay, so the first thing we want to do is factor the denominators. We have an x plus 4, nothing we can do there. X squared plus 4x has a greatest common factor of x, so we can factor an x out of that. And then there's nothing we can do to the x. So once we've done that, our goal is essentially to cancel out the fractions. So I'm going to multiply by our denominators. In our denominators, we have an x and an x plus 4. So I'm going to multiply that to each fraction. So in the first one, the x plus 4 cancels out the x plus 4, leaving an x and an x minus 4. The x and x plus 4 cancels out the x and the x plus 4, leaving a 4. And x cancels out the x, leaving x plus 4, x minus 5. Now we're going to go ahead and multiply this stuff together. We have a distributive property here, so we have x squared minus 4x plus 4. On the right side, these are two binomials. We need to multiply them together. You could do arrows twice, or you could use the box. I'm going to do the box real quick over here. x4, x -5, x squared, -5x, 4x, and -20. So we're going to end up with x squared, 4x, take away 5x is -1x minus 20. All right, the next thing we want to do is move everything to the same side. It doesn't matter what side you choose, but we need to move everything to the same side. And that's because we have an x squared and an x. So I'm going to minus x squared over to here. I'm going to add the 1x over there. I'm going to add the 20 over here. Cancels, 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 equaling 0. You have 24 negative 3x, and x squareds cancel out. All right, so now I'm down to -3x plus 24. So I'm going to minus the 24 over so I can solve for x. So I have -3x equals -24. Divide both sides by -3. And so x is equal to 8. I just have to see if that is a solution or not. So we have to, go back to the original and, plug it in, see if it makes any sense. So 8 minus 8 over 8 plus 4, 4 over 8 squared, 4 times that, 8 minus that, oops. Okay, so we would get, 4 over 12, 4 over, let's use the calculator, x8 squared plus 4 times 8, 96 equals, 3 over 8. All right, so I'm just going to use the calculator here and say, okay, if I have 4 over 12 plus 4 over 96, I get 0.375. 3 divided by 8 is also 0.375. They are the same numbers, so we know this is a solution. Okay, our next problem. We looked at the denominators and nothing needs to be factored, but I notice I have a 5 and an x, so I'm going to multiply each of these by 5x. And so 5x here cancels the 5x here, leaving 1. The 5 cancels the 5, leaving 3 times x. X cancels x, and leaving 5 times 1, which is 5. I'm going to solve the equation. Going to minus the 5 over. We get negative 4 equals 3x. We're going to divide both sides by 3. So we get negative 3/4. To see if that is a solution or if it's extraneous, I'm going to plug it in. So I have 1 over 5 times negative 4 over 3 equals 3 over 5 plus 1 over negative 4 over 3. So I'm going to use my calculator to times the 5 and the negative 4 over 3. I have negative 20 over 3, and it's all over 1. But if we're doing 1 divided by negative 20 over 3, then keep change flip would make it like this, which means I really have negative 3 over 20 equals 5 over 3 plus, once again, we have a 1 divided by a fraction, so that's 1 divided by negative 4 over 3. Keep change flip. 1 times negative 3/4 is just negative 3/4. So I'm going to use my calculator to see if these two things are the same. So negative 3 divided by 20 is the decimal negative 0.15. Using the calculator, I'm going to add the two fractions, negative 3/4, and I get a negative 0.15. They are the same number, so this is a solution. 17, some of our review problems that you can help earn extra credit on to your last test. It's asking us to expand. So here we have log x to the 5th, y to the 2nd. This means multiplication. So if we're expanding, we can write two separate logs with a plus sign between them to represent that multiplication. Then if you have a number in the exponent, we can move it to the front. So it's 5 log x plus 2 log y. You have now expanded. Part B, the fraction is our division. Therefore, when we expand it, it would be considered a subtraction sign. Numbers that are exponents get moved in front. And you've expanded. Part C, when you have a rational exponent or a radical, we're going to write it as a rational exponent. So it's log A times B exponent over index. Now there's a times sign here. We can go ahead and expand that with a plus sign. And if you have a exponent, move it in front. So we would have log A plus 3 over 5 log B. So more of our review problems. So we want to go ahead and get these bases to be the same. So I have a feeling 6 would work. So 6 squared, 6 squared is another way to write 36. 6 to the third power is another way to write 216. Now that the bases are the same, we can ignore those bases and just make the exponents be an equation. So now I can distribute. So I'd have 2 minus 6x equals 3, and I can solve this equation. Minus 2 over to the where 3 is, I'm going to get a 1. divide both sides by -6, so x is -1/6. Our last problem. All right, so we want to get rid of this log. To get rid of the log, I like to multiply in a base of 2 on both sides. So 2 and log base 2 are opposites, so they cancel. So I'm with -5x minus 9 equals 2 to the first power. 2 to the first power is 2. So now I can just solve this equation. I'm going to add the 9. I'm going to get an 11. I'm going to divide by -5. So I'm going to get the answer of 11/5.